Okay, we did some stuff with trig. Now let's use it. Welcome to 12.2. We're going to use our sine, cosine, and tangent a lot. Okay, so now we have been introduced to sine, cosine, and tangent. Now we can start using them to solve things in trigonometry. So for this section, we are still only dealing with right triangles, which is great, makes our lives a little bit easier. Someday we'll get away from those. Who knows? But anyway, it says find the value of x and round to the nearest 10. So step 1, we're going to figure out what to do. Step 2, I'm going to show you how to do it on your calculator. No matter what, you're still going to have to think. So this is why trig is fun. I love it. I love it. So step 1, we're going to look at what we have. Okay, so we have this angle right here. We have the x, which in this case would be our opposite. And then we have this one, which would be our hypotenuse. So now what you need to do is you need to kind of figure out, okay, which one of my trig functions gives me a relationship between the opposite and the hypotenuse. And hopefully you're thinking, and if you don't know them yet, then have like a cheat sheet or something like that so you can look at them. But our sine, yes, we shorten it to sin. It is still called sine. So we can do sine of this angle, sine of our angle, so that's going to be sine of 64, is equal to opposite over adjacent. So that's going to be over hypotenuse over 25. So sine of 65 equals x over 25. From there, we can algebra. We just want to get x by itself. So we're going to multiply both sides by 25 to move it over. So we're going to have 25 times sine of 64 equals x. So now this is a thing that your calculator can do. So let's take a look at that and see how that's done. Okay, so remember our problem was we need to figure out what 25 times sine of 64 equals. So there's a couple things we got to do. So everyone needs to do this with their calculator first. You have to figure out what mode you're in. So if you look right up here, this calculator that I'm looking at is currently in radians. So radians is a different way that we look at angles. We want to change that. So I think we're gonna go to mode, and we're going to see where it says here, radian and degree. We're gonna scroll down. We're gonna change that to degree. You must check your calculator to make sure it is in degree mode. If it is not in degree mode, it will give you the wrong values. Please check it. Anyway, now that we are in degree mode, we can get out of this, and it says degree up here, so we're good to go. So remember, we're doing 25 times sine of 64. So I'm going to type in 25 first, and you can type in times if you wanted to. And then here's our little sine button. Sine, and notice how it gives us a open parenthesis. We're just going to put in 64. Now, if you can leave the parenthesis open now, but I'm going to go ahead and close it just as a good practice. So if you were going to have more of an equation, you would want to close this to tell the calculator that, hey, I only want the sine of 64 degrees, not 64 times this plus that, blah, blah, blah. So we're going to push enter. And our answer, we're going to call it 22.5. So let's go ahead and just get in the habit of rounding to the nearest tenth, and we're going to be good to go with that. So 22.5 equals x. All right, looking at number 3. So we've got our angle right here. We've got this is our adjacent side, and this is our hypotenuse. So we use sine up top for opposite. Here, we're going to use cosine. So we can say the cosine of 18, I'm going to put that in parentheses just for fun, is equal to the adjacent divided by 34. So adjacent over hypotenuse. So that's our definition of cosine. So the 34 is going to go up in front. 34 times cosine of 18 equals x. And I'm going to show you how to do this on your calculator a couple more times, and then we'll just go from there. Okay, so this time it was, 34 times cosine of 18? So 34 times cosine of 18. I know my calculator's in degrees because we just did that last problem, right? So I'm good to go. We're going to push enter, and our answer is going to be 32.3. Last but not least, number 5. Here we are. We're looking at this guy right there, and we have the opposite, and we have the hypotenuse. So that's going to be another sine. So sine is opposite over hypotenuse. So I guess it's a little different. Our x is on the bottom, but that's okay. We're just going to... Oh, I wrote that wrong. I apologize. So that is going to be the sine of 63 equals. Okay, so we're still going to move the x to the other side and then divide by sine of 63. Remember, sine of 63 is just a number. So you can do anything with that you can do with a normal number. In this case, we're going to do 27 divided by 63. So let's see what that looks like. So here we go. We've got, what are we doing? 27 divided by sine of 63. And I'm going to close my parentheses. That should be okay. And we get 30.3. No problem. So up until now, we've been dealing with, okay, we have an angle and a side. How do we find that second side? Well, what happens if we have two sides and we want to find that angle? Well, sine, cosine, and tangent can still help us do that. But this time, we're just going to use the inverse. So if sine of theta equals, let's see here, if sine of theta equals x, then theta equals sine inverse, that's how we signal inverse, of x. And so same thing with cosine inverse of theta, and then, and then theta in this case would be tangent inverse of theta. So what does that look like? So if we're looking at number 7, it says find the missing angle, round to the nearest tenth. So we have both sides, but we don't have the hypotenuse. So that's going to be our tangent of theta. So our angle here would just be so our angle normally would be tangent. Tangent is opposite over hypotenuse, opposite over adjacent. But this time we're just going to use the tangent inverse. So we can write our theta is equal to tangent inverse of 8 over 14. And this is, again, something that we can do in our calculator, and it will give us the answer. So let's check that out. Okay, so we've got our tangent, and we're trying to find our inverse. So normally we would push this button. Instead, notice that right up here, the top of it is tangent inverse, and then blue. So we're going to use that second function. So we're going to push second tan inverse, and then we said 8 divided by 14, so you're just going to do 8 divided by 14. You don't have to worry about making it a fraction. Dividing actually does the same thing. And just for good measure, we can close our parenthesis. You don't really have to when it's at the end. The calculator will do it for us, but it's a good practice to get into. And so this number here means that our angle is 29.7 degrees. So that's our answer. Theta equals 29.7. So the calculator I'm using, it's not my normal one, was not in degrees. And the way I knew that is that my answer was point something, something, something. It wasn't even a full degree, and I knew that wasn't right. So this is an example of make sure your calculator is in degrees, and it's also good to be able to know kind of what the answer should be so that you know when you get a bad answer. So, okay, I got it in degrees, and now it's telling me that my theta is equal to 50.6 degrees. Mr. Lin, when am I ever going to use this? I have a great answer for you. Hey, look, it's a word problem. Yep, that's right. We're going to do some word problems Love doing some trig with some good word problems. Here we go. So number 11 says the angle of elevation from a fishing boat to the top of a lighthouse is 5 degrees. If the top of the lighthouse is 161 feet above sea level, how far is the boat from the lighthouse? So what we can imagine, number one, your strategy, draw a picture. Always draw a picture, draw a picture, draw a picture. So we have a picture over here already, and we're talking about angle of elevation. So this is kind of a slick way of, if you have a known distance, like a lighthouse of a known height, you can figure out how far away you are. You can figure this out by using, they've got these fancy measuring things where you can kind of find the elevation. Your phone can do it too. But anyway, this can tell you how far away you are to like a shoreline. And let's say computers go out and you're on a boat, and this is, a technique they might use. But anyway, so angle of elevation. So this guy right here says it's 5 degrees. And the top of the lighthouse is 161 feet above sea level. How far is the boat from the lighthouse? So we are looking for this value right here. So we can use our trig. So things we have our theta, we have our opposite. We know that this is a right triangle because we're defining this is a height. So that's why we can do this. So 161 feet is our height. So we have our opposite and our adjacent. So we're going to use tangent. So I could say tangent of 5 degrees equals 161 divided by x. Do some algebra. We're going to have x equals 161 divided by tangent of 5 degrees. I'm going to plug that into my calculator, 161 divided by tangent of 5 degrees. And I get, we are 1,840 feet from the coast, or from the lighthouse at least. Okay, we'll do one more word problem. So I skipped down to number 14. I think this is about angle of depression, which just means that instead of going up, you're going down. But you solve these in the exact same way. Draw a picture, do some trig, we're good to go. So a fire is spotted from the top of a 125-foot tall tower. So here's my tower, and this is 125 feet from the top of a 125-foot tall tower. If the angle of depression to the fire, we're going to say there's a little fire here. If that angle is 19 degrees, how far is the fire from the base of the tower? So we are looking for this value right here. So we've got our theta, and we are looking for the opposite, and we have the adjacent, so we're going to use tangent again. So tangent of 19 degrees equals opposite over adjacent. And then we're going to move the 125 to the other side. So it's going to be 125 tangent of 19 degrees equals x. So I'm just going to throw that in my calculator. Times tangent of 19. So that means that our x is equal to 43 feet from the tower. That seems a little close. I'm a little worried. So, okay, now let's talk about this. Like when we're doing trig and stuff like that, are you ever going to be doing trig on a calculator, or whatever? No, but what about the computer programmer? Maybe you can set up a program where all you do is you measure something, just type it in, and it'll spit out the answer of how far away something is. So that's why it's important to kind of know some of this stuff so that you can then solve some of these problems and maybe even create new things that use these things. So Here we go. It's trig. Try some on your own. I will see you in class.